G'day. Today's video is inspired by this thing. This is a grabber, and there's a handle down one end and you pull that and it does that. Now, near where I work there's an artificial lake, and unfortunately it's also next to a shopping centre and a school and a few other things, and so litter gets blown in there. Not necessarily intentionally, but just it ends up in there. And I was walking around there the other day thinking it'd be nice to be able to pull that out, and I suddenly realised, well, I have the technology, I just need to make it bigger. So this video is about making up a set of grubbing jaws, and I'll show you the way they work, and doing a little bit of machining to make a set. The original grippers are quite good in that they've got some V-grooves there to grab things. There's a little magnet there. When they're closed, there's a small V there and a large pocket there with a little notch there so that you could grab a round thing. The only problem with them really is that they're a bit too small for me, so I'm going to scale them up a little bit. But other than that, they work quite nicely. Now, the mechanism that they use to close is this. There's a couple of half gear segments, not even half really, about a quarter of a turn, maybe a little bit more of a gear segment there, and there's a double-sided rack there, and so when the handle is squeezed and that rack is pulled, it brings the jaws in, and I quite like that. It's not a new device, it's been used before, and I think there was a Christmas special once that made something like this for, might have even been this old Tony. But anyway, so that's the plan. So I'm going to rough out the jaws, or I'm going to cut out the jaws, and then I need to put them up on the dividing head and cut some gear segments. One nice thing about cutting gear segments like this is that because it's not a full circle, they don't have to meet. So if you're a little bit out in your cutting, in your indexing, it's not going to worry you. I've machined my blanks down to width, thickness and length. I actually cut out 3 bits of material and took it down to 20 millimeters, and the third one's just sitting there as a reserve, and I also need something to cut my rack out of later. These ones are the size of the jaws. I marked the position of the pivot hole, and then I've drilled a 1.5 millimeter hole through there, and that's simply so that whether I'm on this side or whether I'm on this side, I've got a marker as to where that hole is, where that dimension is. I could have marked out on both sides, but drilling a small hole is something that I do for this sort of thing. So what's got to happen here is that I've got to have a quadrant in here, and I've got to have these jaws coming up doing that thing. One of the things about machining plastic, and I've mentioned this on the lathe, is you want to keep your feed rate up so you don't get lots of fluffy chips. Same applies to milling. Here I probably could have done with a faster spindle speed to get a slightly better surface finish, but that doesn't worry me too much at the moment. But for those of interest, the clip I had where I was just taking a bit off the top there, the clip that you just saw with when I was taking material off the top here, the feed rate set to on the machine was 524 millimeters per minute. That's the second fastest feed I've got on my mill, but you need that so that you get proper chips rather than fluffy things. This is the shape that I'm trying to achieve, and this has got, I've got my dimensions in black here, but I've also got some in red, which is what the cutter path is going to be when I offset things. I want to hollow it out and get it a little bit light if I can. But one of the important things is this gear sector here has to be identical on both parts. They both have to be symmetric, so that if you can imagine you've got your gear teeth and you've got the rack pulling up, they're both going to move at the same time, rather than one sort of being a little bit offset so it starts move, or it not starts moving, it moves in a little bit more than the other one. I guess in the end of the day it doesn't matter too much because they're still going to close, but I'd like to get it symmetric. So what I've done, I've got my blocks of plastic, I drilled a 1.5 hole in through there to give me a location, but what that'll also allow me to do, I've got a bit of 1.6 welding rod, stainless welding rod, and I've just knocked that through there, nailed it through, and that's that pivot point there. I'm also going to put a couple of wood screws through here to hold this together, and that'll give me basically one block of plastic, so I can mount that up, I can cut my teeth, I can do my operations, leaving this cut out till last where the screws are. All I want to do with this setup is round off the end there and then round off the face from a gear, possibly come in and put the end of the gear there just so I've got a nice neat line to work to. To do that, I've had to go through my cutter drawer, and this is the longest one I could find, so this is what I'm using. It's 1/2 inch. The offsets I carefully put on my drawing were for a 10mm cutter, so of course everything is out, but that's all right. So I wouldn't normally attempt this depth of cut on a bit of metal, but plastic, relatively soft, I think I'll be pretty right. I might do half and then step down, I think, but we'll see how we go with that. And that should let me round those off. That one's important for the gear teeth. This one here is just clearance, so that when it rotates around that point, I haven't got sticky out bits that are going to jam. That's that bit basically done. I'm going to come around here and just sort of clear out that little pocket there, because it'll be an undercut if I come in there with a straight milling cutter, which is the plan. I guess the big change here is that I put another stop in there. When I did this side, I put it over here. When I've swapped around to this side, I've put it here, and that's just because even with reasonably tight clamping, this plastic wants to move. It's acetyl. It's one of the better plastics for machining, but even so, it'll squash, it'll move if you give it a chance. So I found that I when I started coming in, I was getting a bit of a mismatch in where I expected the cut to be compared to my pencil lines, and so I recentered and put that extra clamp there. I also had to remove one of the parallels that was sticking out here, because this corner would have just obliterated it. This is probably one of the dodgiest setups I've used for quite some time. Let me explain what's happening here. There are my blanks, and I want to cut gear teeth on them. So I've got the centre of that radius lined up with the centre of the rotary table, and I did that when I was horizontal. Because of the size of that cutter, I've had to space that out from the table so that the cutter has got room to get past half its diameter while cutting these things. So there's that. I've had to space the table up with some parallels, because when that was rotating round, it didn't quite clear. I'm using the rotary table rather than the dividing head because it gives me more room to clamp, but I've set this up in its as a dividing head. This is normally a holder I use for slitting saws and that sort of thing, and they're very simple to make. It's basically just a sleeve to the inside bore of the slitting saw, and there's also that bore is the inside of here, and then you put your slitting saw on. There's a hex head, a socket head cap screw that goes in there, screws into here. Everything's wonderful. This one, the cutter is a 22 bore, so I've had to make up a smaller diameter. What would you call it? Mandrel, spindle, I don't know. But because it relies on basically the fit between there and the bore of this for dimensional accuracy, I've also had to make up a little bit of a spacer. So in here there's a smaller version of this with the cutter and then a spacer to take it out to 25, and I'm hoping that'll stabilise that enough. This particular collet holder here is one that I made up some time ago, and there's a video on that somewhere. And it was for this sort of thing where I needed to get in close to a shoulder or a step or something. I didn't have room for a proper collet down here, so the actual collet is here, but the chucking part is there, and this is an ER25. But as you can see, that's just the same size, or just a little bit smaller, I think, than the fly cutter thing. So that's all good. That gap is because when I made this, I didn't anticipate having something as long as this. So that might be a remedial thing I'll do later on, is make that a little bit deeper. I have my two jaws roughed out. I need to take out the inside here, but as you can see, the gear teeth are fine. I now need to create a small piece of rack that'll sit in between here, and so I've got this bit of acetal set up in the homemade vise on the homemade angle plate, and I'm just going to go along and then index up the circular pitch of the gear, and that'll give me a rack. I'll then flip that over and do the same on the other side, and I'll have a double-sided rack that'll sit in there. Unfortunately, I'm not feeling 100%, so I'm going to have to leave it here, but I'll show you what I have managed to get done. So there's a bracket for putting the two jaws into, and if I just do that, and put my jaws up there, I've put a flat on there to act as a backstop when this thing is fully open. And but there's the action there, so that all works nicely. This has been made up to go into a 25mm OD tube, and I'll put a bolt through here into a 16 inside that, so that at the other end I can have a squeezy handly thing, and it'll close up. I've still got to take off this excess material. I've still got to put some weight relief in here. I was going to take that all the way up to the ends there, but I think I'll leave that for the moment, just in case I decide to screw some rubber pads or something like that onto the end there to make it grab a bit better. At the end of the jaws here I've got a stainless steel bush, and the idea is that will clamp between the two aluminium plates here and be solid, and that the arm pivots around that the OD of that bush. So I figured that's probably the safest way of getting a nice hinging arrangement there without the possibility of excessive wear. But there we go. So thanks for watching. See you for the next one.